3.4 is about function notation. So our essential question, what is function notation and how do we use it? An algebraic expression that is defined as a function has a function rule. The independent variable is your x value. The dependent variable is your y value. So in this case, it's not optional. X is always independent. Y is always dependent. And the function notation is saying that y is equal to f of x. We read this as f of x, where f is the name of the function. So this is really just fancy notation that it gets used in all of your future classes, but really it's the same thing as saying y equals the function. Y equals the x stuff. In this case, we're calling y f of x. It's a fancy name for the function. So the dependent variable is a function of the independent variable. So most of this section is really just understanding what the notation is asking you for, and once you understand that, it's really just identifying or plugging in values. So for example, on part A, this says f parentheses 1. Out loud, that means f of 1. So what that means is, what is y, or what is f, when x is 1? So looking at the graph off to the right, when x is equal to 1, where is the closed circle? Well, when x is equal to 1, we're right here. F of 1 is going to be equal to 4. And we could also write that as an ordered pair, the ordered pair 1, 4. When x is 1, y, or fancy name f of x, is equal to 1. So this second one is saying when x is 6, what is y? So going over on my graph, looking for the closed circle when x is 6, and that's right here. When x is 6, y is 2. So f of 6 equals 2. Or 6 for x, 2 for y. Part C, when x is 0, what is y? So looking at the looking at the y-axis, x is 0 right here. That looks like it's a little bit more than 4. Let's just call it 4. So we could write that as an ordered pair, 0, 4. So again, the notation is the thing that's confusing here. So pause the video and see if you can complete part D. Part D is asking us, when x is equal to -4, where is the function? Or when x is equal to -4, what is y? So going to -4 on the x-axis, something to notice, this is an open circle. There's no closed circle like there was when x equals 1 or when x equals 6. So that actually means that f of -4 does not exist. There is no value when x is equal to -4. There's no closed circle anywhere on the graph. Now E and F look a little bit different. Notice that there's no number inside parentheses like there was on A, B, C, and D. The number is on the other side. The directions here say find x when f of x equals 2. What this means is when y, or when the y-axis, when the function is at 2, what's x? So go ahead, look at the graph and look for where the function is equal to 2. I'm going to go ahead and erase these other lines from A through D. So let's look at y is 2 right here. I'm going to draw kind of a dotted line, not very well. Looking at my dotted line, where, if anywhere, does the red function cross the dotted line? Well, it crosses the dotted line when x is equal to 6. And again over here, whatever that value is, we'll call that 5. When x is equal to 6 and 5, y, or the function, is equal to 2. So for part F, pause the video, see if you can figure out what x values make the function -2. Pause the video and test that out. So looking at -2 on the y-axis, that's down here. There's an open circle there, so that doesn't count. Right here is going to be the place where y is -2. What is x there? X equals 4. So recapping that notation, the number inside parentheses is what you're plugging in for x. That's why we're saying f of x. If there is a number in there, we're plugging that number in for all of the x's. So if it said f of 2, I'm plugging 2 in. If it said f of 5, I'm plugging 5 in. If it says f of x equals a number, then what we're doing is finding out where what x value makes the function that number. Let's look at some more examples. Evaluate each function for x equals 7, x equals -4, and x equals y minus 3. Also write answers as ordered pairs. So what these directions are saying, and I'm going to use a different color for each of these things. What these directions are saying is plug in each of these numbers. So plug 7 in for x into this function. So 3 times 7 plus 2. 3 times 7 is 21. 21 plus 2 is 23. If I was going to write this as an ordered pair, that would be 7, 23. If I plugged 7 into G, look, this is a different letter. It doesn't change anything about the problem. It just means this function's name is G instead of its name being F. So G of 7 equals -2 times 7 minus 5. So I'm just using the function they gave me and plugging in the values. -2 times 7 is -14, minus 5 is -19. If I was going to write this as an ordered pair, when I plugged in 7, I got -19. Why don't you go ahead and pause the video and do this exact same thing on both numbers 1 and 2 for when x equals -4. 3 times -4 plus 2, so 3 times -4 is -12, plus 2 is -10 when we plug it into into f. So when x is -4, the function is -10. For number 2, if I plug -4 into G, -2 times -4 is +8. 8 minus 5 is 3. So when we plug in -4, we get +3. The last one is a little challenging, a little different. What are we plugging in? We're plugging in y minus 3. So we're plugging in not a number, but an expression. In terms of the math we do, that doesn't actually change anything. It just means our final answer isn't going to be a number. It's going to be an expression. It's going to be something that still has a variable. So I'm saying 3 times y minus 3 plus 2. Well, if I distribute, that gives me 3y minus 9 plus 2. And if I combine -9 and 2, that gives me 3y minus 7. So when I plug in y minus 3, I get 3y minus 7. The process is the same. It just feels a little bit weird to still have variables in your final answer. So pause the video, try and do G of y minus 3. So we're substituting y minus 3 in for x. Then we're going to distribute -2y plus 6 minus 5. Then we're going to combine like terms, -2y plus 1. So G of y minus 3 equals -2y minus 1. As an ordered pair, the x part was y minus 3. The y part was -2y plus 1. All right, our last two examples. Now these functions are sort of scary looking because they have the weird squiggly bracket, they have multiple parts, and they just in general look kind of scary. And it also probably doesn't help that this whole thing should be over here. We're going to evaluate when x is equal to -1, 0, and 2 here. So I'm going to cross this off. So here is our function. This is called a piecewise function, and it's called a piecewise function because it has multiple pieces. In fact, it has 3 pieces. It has this piece. Oops, I didn't want to cover that up. It has this first piece. It has this second piece. And it has this third piece. The thing that's confusing about these functions is when to use each piece. And there is only a specific domain when you're going to use each value. So you're not plugging in each of these numbers into all 3 places. So I'm going to rewrite out what we're supposed to do. We're supposed to find f of -1, we're supposed to find f of 0, and we're supposed to find f of 2. Now, each of these numbers only falls into one of these categories here. So the number 1 category, okay, I'm going to erase that, too hard to read, is for all values of x where x is less than 0. So you will use 2x for all x less than 0. So that's the function that I will use. So let's look at these three numbers, -1, 0, and 2. Which of those is less than 0? The first one. So for the first one, I'm using 2x as my function. So I'm going to plug in 2 times -1. That's going to give me -2. The second piece is not less than 0, so I can't use that piece. The third piece is not less than 0, so I can't use that piece. If I was plugging in -100, I would use that first piece because -100 is less than 0. The second piece of our function, the one that I wrote a little 2 by, says we use x if x equals 0. That's the only time it happens. Well, here we do have x equaling 0. So for this, we're going to just plug into x, which means we're just going to get 0. F of 0 equals 0. We use the third function, which is x plus 2, for any number, for any x that's more than 0. So 2 is more than 0, so I'm going to use x plus 2 for the number 2. I'm going to plug in 2 for x. That's going to give me that f of 2 is 0. So if I was plugging 5 in, I would put it in the green one, number 3, equation 3. If I was plugging in -12, I would put it in the first one. So you're not plugging it into 3 different places. You're plugging it into the place that it goes, the room or the spot that the function it's supposed to be with. Okay. Number 4 also got a little off track. There should be a 20 and a 30 over here, not over here. So how many pieces are there of the function in number 4? There are 4 pieces. Here's the first piece. Here's the second piece. Here's the third piece. And here's the fourth piece. And there's something that's even weirder about this one. Look at each of those pieces. There aren't any x's there. So what that means is every number that falls into the category, the answer is this number here. So these are all of our answers. No matter what you plug in, the answer is either going to be -4, 25, 16, or 10. Those are the only possible answers. So now you just have to figure out for each of the values you're plugging in, which answer goes with that number based on the domain, based on the intervals that we're plugging into. So let's look. I set all of them up. I'm going to just start by putting a dot for the color that goes with it. So 0 is less than 6. So take a minute, identify for yourself which color is that going to go with? Red, green, blue, or purple? Less than 6. 0 is less than 6. So this is going to go in the red equation. 7 is going to go in the green equation because 7 is in between 6 and 8. As opposed to 0 is less than 6. 10 is not between 6 and 8. 10 is between 8 and 30. So that 10 is going to go with the blue one. 20 is also going to go with the blue one. 20 is between 8 and 30. And then last but not least, 30 is going to go in the bottom one, the purple one. So first, identify, and I like to number each of those different pieces of the piecewise function. Then figure out which values are getting plugged into which piece. So now everything that falls into the red category, the answer is 4. Everything that falls into the green category, the answer is 25. Everything that falls into the blue category, the answer is 16. Everything that falls into the purple category, the answer is 10. Unlike this problem that we did for number 3 where there were x's, so we actually plugged our x in for x. On number 4, there are no x's or t's in this case in the actual function. So f of 0 is just going to be -4. F of 7, 25. I'm just getting these numbers from this answers column here. All the blue ones are 16. All the purple ones are 10. So to recap these notes, f of x or g of x or q of x or choose your favorite letter of x is just a fancy way of writing y equals. It's function notation. You will see that used very, very often in future math classes. When there is a number inside, that means plug that number in for the variable in every place where that variable is in the problem and simplify. You can write those answers as ordered pairs. The number you plugged in, comma, the number that you found when you plugged it in. These last piecewise functions, my advice to you is to number each individual piece and to really take that time to figure out which piece goes where. Don't worry, we're going to be working more with problems like these during class, and I look forward to supporting you there. Thanks for listening.